Second part of today's lecture is where are we? So what is our place in this vast universe? And then later we'll get to how did we get to this place in this vast universe? And then we will get to how are we moving in this vast universe? So this is a quote that I quite like. It's from Homer, back when The Simpsons was very good. I'm a lonely, insignificant speck on a has-been planet, orbited by a cold and indifferent sun. A pretty deep quote, but of course it's wrong because the sun is not orbiting the Earth. So that was back when The Simpsons had these kind of academic jokes. I really liked that, and it wasn't just Homer falling down repeatedly. A better definition is that we live on a rocky planet in the inner part of the solar system that orbits an average-sized star, the Sun, in the outer part of a large galaxy inside a small group of 30 galaxies in our local supercluster in the universe. For the purposes of your course here, these few weeks, we want to understand this stuff in the context of the effect that it's going to have on the spectrum. And so we're going to try and understand our place in the universe in service of understanding this spectrum. So it's a bit backwards. Usually when I teach the students in the 100 level class, they really do have to learn about all of this stuff. We're mostly going to be concerned about how our location affects the observation. So this is kind of a schematic of where we are. We're, of course, in the solar system. There's the sun. Here we are, third planet from the sun. We are on the outskirts of the Milky Way galaxy, and that turns out to be pretty important for your observation. When you're observing, you will be observing H1 in some direction across this galaxy. And the direction that you're pointing your telescope will affect the observations. If you're pointing the telescope towards the center of the galaxy, you get a lot more signal, higher intensity, more kelvins of intensity in our favorite unit. If you're pointing the telescope opposite the center, then you get less. You still get a detection because there is so much hydrogen out there, but it's going to be weaker. If you point your telescope perpendicular, so the galaxy is a plane, it's kind of flat like a pancake, as we'll see in later lectures. If you go perpendicular to that plane, then you might not see very much hydrogen at all. That hydrogen layer is relatively thin, and if you go out of it, you are sensitive to less gas than if you go through it. So the location of the sun in the outer part of our galaxy is actually really important for your observations. Yeah, the density is very low. I mean, the density is very low in general in space. So in order to make a star, you do need relatively high density. The gas that you are sensitive to with your little radio telescopes is relatively low density. So our own Milky Way is here. We're on the outside of it. We're in a local group of about 30 galaxies. The Milky Way is one of the largest galaxies in the local group, together with Andromeda, which many of you have probably seen. You can actually see it with your naked eyes in a dark sky environment. And then the local group is in a local supercluster, and then the universe is made up of superclusters. We'll get into some of this later. For now, I just wanted to orient yourselves with the broader scheme of things, again, in the service of understanding that spectrum.